Okay, in this video, we're going to assume that we already know that the vertical acceleration is this much. That's what we figured out in the previous video. Okay, and we're going to actually figure out these two things: the time that the electron takes to go from here to here. Okay, and then the horizontal velocity that the electrons have to have. Okay, so if you look at this thing, they enter midway between, right? It doesn't look like they do, right? And they don't exit midway. They actually exit almost hitting that plate there. So the displacement downward here is half of this total distance. So it's, what is it? 5.1 centimeters. So that's 0.051 meters is our displacement downward, right? So now we just set up a horizontal vertical thing. Let's do it over here just for fun. We got a little more space. Okay. Okay, so here's horizontal, here's vertical. Set up our things that we know: S, U, V, A, and T. S, U, V, A, and T. Right? And then horizontally, we know that our horizontal distance is 0.175 meters. We know that our horizontal velocity is what we'd like to know, right? And these guys are the same thing. Okay, our acceleration horizontally is 0 because there's no electric field sideways. It's all up and down, right? Time, we don't know. Okay, vertically, our displacement is negative 0.051. Our initial vertical velocity is 0, so it's like a cliff problem, right? We're coming straight this way, right? The velocity is exactly straight this way, right? Okay, our final velocity is, we don't really care, right? And our acceleration is downward, negative 1.65651 e minus, or e to the positive 15th meters per second squared, right? So now we know this, this, and this, and I believe we can find the time here, right? Using this, S is u t plus 1/2 a t squared, right? So now we want to solve for t. The initial velocity is 0. So if we solve that for t, we get 2s over a is t squared, and then we can square root that and get the absolute value of t, right? Which is what we want. So I'm going to go square root of 2 times our s is negative 0.051. Okay, and then we're going to divide by the acceleration. And I'm going to store that in t. And I get not very many seconds. Okay, I'm getting that t equals 7.84698 e to the minus 9th seconds, nanoseconds. Right, so our time is now 7.847 e minus 9 seconds, and then time is on both sides, so we can pull the time over there. 7.84698 seconds. Oh wait, e minus 9, right? Seconds. Okay, so now we're all set here. We know the distance and the time, so we can find the velocity, right? So the horizontal velocity, horizontally, right, is equal to distance divided by time. So it's 0.175 horizontally meters, right, divided by that time, 7.84, this guy right here, 847 times 10 to the minus 9th seconds. Now, of course, I'm going to use my exact value here, so 0.175 divided by the answer that's on my calculator. Okay, and I'm getting that the velocity is, oh yeah, here we just got that answer there. I'm getting this velocity here, the 223.01572 meters per second. So 1, 2, 3, 4, 5, 6, 7. So 2.23 times 10 to the 7th meters per second. Okay, so there's that. So this is just a SUVOT problem. The acceleration is from your electrical calculations there, right? Remember that there's no acceleration in the direction the electron's traveling initially. The acceleration usually is to the side due to the electric field. Okay.